Today I am going to solve a Leetcode problem on March 8th. Problem is minimum recolors to get consecutive black box. Problem is minimum recolors to get k consecutive black box. Let us see problem statement. You are given a zero indexed integer block of length n. We are given an integer of length n, of string of length n, where blocks of I is the either white or black. Let the block is equal to it, which consists of white or black. W denotes white, B denotes black. B denotes black. You are also given an integer k. We are also given an integer k in which it is a consecutive black box. It is the, what does this k states that it is a consecutive number of black blocks. It is a consecutive number of black blocks. Let us see one condition that is stated in this problem statement. In one operation, you can recolor a white block into black block. In one operation, we can convert white block into black block in such a way that we convert white into black, we get a blocks consecutive black box. We can get a consecutive black box. We should return the minimum number of operations needed for this operation, for this occurrence of consecutive black box. Let us see this with an example. You get clearly. By seeing an example, we can get an idea of what to do. Let the block is equal to W, B, B, W, W, B, B, W, B, W. It is the example 1 in which it is a block of length n and we have given block consecutive block size of k that is equal to 7. We should get k is equal to 7 consecutive number of blocks. We can convert white color into black color. Minimum number of operations to do this. First, we go through the brute force. First of all, we do the brute force approach. For this brute force approach, we consider the block size of k for every iteration. Block size of k. Let the given is W, B, B, W, W, B, B, W, B, W. Let us consider, first of all, we consider block size of 7. It is block size of 7. In this block, how many number of minimum operations required to convert white into black? That is 1, this is 2, this is 3. In this block, we can get 3 number. We store this in 3 value in result variable. For this block, the minimum number of operations is 3. Let us consider the next block. We consider for this block. For this block, we get minimum number of iterations is 1. This is 2. We can convert this element, this element, this element. In this, result is equal to 3. For the next block, this is the next block. This is the next block. This is the next block. In this block, we get how many minimum number of iterations is in this block. In this block, minimum number of iterations is, number of recoloring is, it is 1, it is 2, it is 3. In this also, it is 3. For the next block, this is the next block, this is the next block. For this block, the minimum number of operations is, it is 1, it is 2, it is 3, it is 4. We take 4 number here, the number of possible operations is 4. We should return the minimum number of operations. That is, from this, we get the minimum number of operations is 3. This is the brute force method, in which it takes O of n into k time complexity. O of n into k, which is maximum. It is nearly equal to O of n square. O of n square. For this, the optimized approach could be, optimized approach is optimized approach is using sliding window. This is the one of the algorithm to solve the problems, in which when we are asked to find subarray sum, maximum subarray sum, and minimum sum, and what would be the negative number in the given subarray. When they ask subarray, we first try an approach called sliding window. It is the one of the important, my dear friends. Please understand, I will discuss the approach, how this sliding window occurs. All of you know that window will be sliding. Sliding window. In our homes, we will be having sliding window, in which it moves with a constant size or fixed number of size. Let the elements be 1, 2, 3, 4, 5. If we are asked to find out the k is equal to 3 number of size, it would be the first window. The next window would be this. The next window would be this. This is the sliding window, in which it will be sliding based on the fixed length of k. How this sliding window approach would become fixed, for this problem is, let us take one. I am explaining one example how this sliding window occurs is, if they are asked to find out the subarray sum, of size k, that is equal to 3. If the subarray size of k is equal to 3, let us first consider this subarray. For this subarray, the sum is 6. For the next subarray, listen, this is the important. For the next subarray, this will be the subarray, and what will be the sum is, we just subtract this element. That is, from the previously calculated sum, we would subtract this element, and we add this element. We add the next element, that is 4. That is equal to 9. We would see if it is 9 or not. 2 plus 3 plus 4, that is equal to 9. This is the sliding window approach, in which we remove this first element and we just add the next element. In this, we require only O of n complexity. This is the approach to solve this problem. I think all of you got this idea why only sliding window approach we should follow. The sliding window approach, because we should do in an optimal solution. We should find optimal solution. Find the optimal solution. Let's see the problem, the given problem. Let the block is equal to W B B W W BBW, 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 BW. Let this be the block and given block size of k is equal to 7. Given block size of k is equal to 7. First, we should take and initialize the variables. That is, left is equal to 0 and right is equal to 0. At first, we should keep result because we should find out the minimum value. We consider this as a maximum value, integer dot max value. We take it as max value, result as max value, and the recoloring required. Let me initialize with using 0. Number of recoloring required is 0 at initially. Now, for every iteration, that is for every R increment, if the element at R is white, we increment the recoloring value because white given condition is white can be converted into black. White can be converted into black. So for every iteration of the increment of right value, if the element value is white, then we increment the recoloring value. It is the first step. The next step is if block dot caret of right double equal to white, we just increment the recoloring value. Recolor plus plus. We increment the recolor. Now, if we get the block size of, if we have got the block size of k, that is, if we let's suppose this is block of size 7. How would we know this block size have achieved? Because it is left. I have said only we increment the right value. If we have got the block size, how can we find this block size is we just right minus left plus 1. This is block size. We subtract right value minus left value plus 1. If it is double equal to k, here we have achieved the block size. We have achieved the block size of size k. We increment left. We increment left only in the condition where character of left double equal to white. If we have got that block size or character of at left is equal to white, we decrement because we are excluding this element. I previously said we should remove the left element. We should remove the left element and add the next element. That means removing the left element means recoloring the recolor of minus minus. When only in the condition if block dot caret of left double equal to white. This is the next condition. And we increment left plus plus. We increment the left plus plus. This is the condition. At last we calculate the result. That result is math dot min. It is the function which is used to find the minimum value in the previously calculated result value and recoloring value. Why we are, once again I will explain this pseudocode. Why we are calculating the result? Because we have attained the block size of k. We have attained the block size of k. After the calculating of the block size of k, We calculate this. If it is left is double equal to white, we decrement the recoloring value and we increment the left value. For we are adjusting the left and right. I hope this is clearly understood for everyone. This is the optimized approach of sliding window. Let us code this problem statement. Let us code this problem statement. Given it is 2379 problem. Initially, what I have said, we take int left is equal to 0. Int result is equal to integer dot max value. Integer dot max value. Let me keep my pad on the other side. That result is equal to integer dot max value. Now int now we initialize int recolor is equal to 0. Initially recoloring is equal to 0. For of int of we initialize right is equal to with 0, right is lesser than n. Let right is lesser than block dot length, right plus plus. First we should increment the, if it is character at right is double equal to white, if block dot caret, it is a function which is used to find out the caret the particular index, right, double equal to white, we just increment the recolor value as plus plus, recoloring value as plus plus. Now if we have attained the maximum block size, that is left right, we have attained the right minus left plus 1 is double equal to block size, we have attained the block size length, that is right minus left plus 1 double equal to k. If it is attained length of k, then we calculate the minimum value of previously calculated result value and recolor value. Now for we have attained the block size value. Now we do left increment. Left increment is only when left is incremented and if the left element is white. I have said if the left element is white. For the decrement of recoloring, we keep this condition. If blocks dot char of left double equal to, because it is char, we should in Java we should keep only single inverted commas w blocks dot caret of left, we decrement the recolor value and we increment left plus plus. At last, after completing of the all iterations, we return answer. We return answer. Let us see. It will be submitted, my dear friends. It is the approach to solve this problem. It is the approach to solve this problem. I think this problem is clear to all, and sliding window concept is also clear to all. I hope you all get submitted this code will be submitted. Thank you, my dear friends. Subscribe to my YouTube channel and share with your friends. Let's meet on the next day. Thank you.